In this question, we're going to use implicit differentiation to determine dy dx. Well, we have this expression here. What we're going to do is take the derivative of every term in terms of x. So we think of this first term as 6x times y squared. Derivative of the first with respect to x is just 6 times the second, which is y squared, plus the first 6x stays 6x times derivative of the second. And here's where we use the chain rule. The derivative of y squared with respect to y is 2 times y to the exponent 1 times the derivative of the interior of that bracket with respect to x. Well, the bracket in this case is y. So the derivative of y with respect to x is simply dy dx. So this is actually an application of the chain rule used to determine the derivative of y squared with respect to x. Now, we still have another term on the left-hand side, 2y. Well, the derivative of 2y with respect to x is 2 times dy dx. The derivative of 1 with respect to x is 0. And at this point, we multiply 6x times 2y and we get 12xy. And we have 3 terms on the left, and 2 of them involve dy dx. So we're going to try and isolate dy dx. We get keep these 2 terms on the left, and we subtract 6y squared from both sides. What we can then do is common factor out dy dx, and we have 12xy plus 2 as our second factor. And now what we can do is divide each side by 12xy plus 2, and we get here. We notice at this point that we can actually factor 2 from both the numerator and denominator. We do that and simplify our expression as shown.